Understand the chemistry of complete combustion. During the complete combustion of any organic compound containing carbon, hydrogen, and/or oxygen, all of the carbon atoms in the reactant are converted entirely into carbon dioxide, CO2, gas. Relate reactant mass to product mass. Since we are starting with equal masses of each compound, the mass of CO2 produced is directly proportional to the mass percent of carbon in the starting reactant. Mass of CO2 equals mass of sample times percent C by mass times molar mass of CO2 over molar mass of C. Therefore, the compound with the highest mass percent of carbon will yield the greatest mass of CO2 upon complete combustion. Determine the mass percent of carbon in each compound. Because calculators are not permitted on Section 1 of the AP Chemistry exam, a student can quickly estimate these percentages by comparing the mass contributed by carbon to the total molar mass of each molecule. Benzene. C6H6 carbon contributes 6 times 12 is equal to 72 grams per mole out of a total molar mass of approximately 78 grams per mole. Percent C equals 72 over 78 times 100% approximately 92.3% cyclohexane. C6H12. Carbon contributes 72 grams per mole out of a total molar mass of approximately 84 grams per mole. Percent C equals 72 over 84 times 100% approximately 85.7% glucose. C6H12O6 carbon contributes 72 grams per mole out of a total molar mass of approximately 180 grams per mole. Percent C equals 72 over 180 times 100% equals 40.0% methane. CH4 carbon contributes 12 grams per mole out of a total molar mass of approximately 16 grams per mole. Percent C equals 12 over 16 times 100% equals 75.0%. Compare and select the correct option. Benzene, C6H6, has the highest mass percent of carbon among all the choices, approximately 92.3%. Thus, burning a sample of benzene will yield the greatest mass of CO2, making option A the correct answer. The correct answer is option A, benzene, C6H6.